All right, hello everybody. Thanks for joining us on this integrated electronic controls and telemetry. So we've identified that there's been a lot changing in the industry, and so we thought we'd put together a three-part series. The first part being around, the electronic controls and how the telemetry goes together. Again, I'm Trent Tegg. We have Trent Kangas on here. You'll hear me refer to him as Kangas all the time because he came into the company second, so he is now Kangas. So Kangas, would you like to introduce yourself?
Yes, I'm Trent Kangas. Been with Applied Fluid Power for a little over 7 years now. My role is an electronic integrator, integrating electronic controls with hydraulics, mainly with mobile hydraulic equipment, although I do have some experience with industrial as well. Anything from displays, controllers, telematics, you name it. That's kind of the role I play.
And I guess I should probably cover in that piece real quick too. So my role within the corporations, I work within the P1 engineering team. So I do national sales and engineering, working with all the different companies across the nation as we go from east to west. So we'll move into the next piece. So you want to walk them through what we're gonna cover?
Yeah. So our agenda here is, first we want to kind of a little bit talk about the evolution of the industry. How some things came to be, review a control system redesign that we had, kind of show you how we can simplify some of the older or existing control systems out there, walk through a few different system integrations here from a high level down to a low level, kind of show you how each of those three categorizes and how we can play a part in all three. And then in the end, how we can integrate telematics into your control system.
And I kind of want to backstep on the very beginning of this. So the evolution of the industry, many people are at many different stages through this path. We still got many people that are on tier 3 engines, so they bought them out. They don't have to worry about the G1939 engine communication. So they haven't moved forward into this technology piece, and I'll get and understand that some people have or are onto different technology platforms using CAN controllers or CAN style wiring. But we're going to be breaking this down from the beginning, rudimentary, because we're going to have all levels of people that are on here with us, and we want to be able to core it. But we'll make it interesting for everybody and make touch points. So I think that'll be of interest to everybody on this meeting.
Exactly.
So one of the main pieces here that's really helped change the industry, and that's why we put it right in the center, right? So the tier 4 engines. So tier 4 engines was the big evolution of a manual controlled engine into electronic controlled engine. All around the synergy of controlling emissions. But when we controlled emissions, what it did is it gave us the ability to greatly enhance our capabilities when it comes to hydraulics and controls and engine communication. Because that along the way has always been one of our challenging points was, reading engine RPM, reading horsepower consumption, reading turbo consumption, all of that stuff happening in the past was something that was very difficult from a hydraulics engineering standpoint and electronics engineering standpoint to how do I make the system best operate. And that's one of the things that we're going to focus on. I think most people on this call have already heard of G1939. They understand what tier 4 engines are. They know that tier 5 is coming out. But again, the biggest piece was, getting rid of that black smoke. When that engine bogged down, when that black smoke came out, that was one of the main focus points. If you're working with one of the applied fluid power engineers and you're doing a system design, one of the things is we're going to work with your Caterpillar, Cummins, Deutsch, whoever you're working with. We work with those guys to help optimize the engine performance. And that's what they are ultimately worried about, engine performance. So when they come in to validate and approve an engine platform, we're working with you to understand that piece. And then we'll kind of walk through, Kangas, if you want to walk through the other pieces of the CAN bus, how this works a little bit.
Right. Yep, exactly. So back to kind of the evolution of the industry thing, like Trent said, it kind of started around the engines, right? Emissions maybe even started as soon as hydraulic load sense. We started things like, sensing load being able to sense your load and back off your pump stroke to basically become more efficient with your engine. Well, now we're even going further with electronics, right? CAN bus is integrating all these devices. your controllers, your displays, your telematics, it all. And there's not only is it integrating it, but we're simplifying things and gathering more data and being more intelligent with our system overall. We got things like, not only just engine diagnostics, but now we have all our machine or controller diagnostics as well. And keep in mind, this is all over just 2 pieces of wire, right? It's a serial communication over 2 pieces of wire instead of point-to-point wiring for everything.
Yeah, and one thing is I want to do, because we start at the beginning that we keep this simple, because not everybody's up to speed with load sense. Obviously we got gear pumps, we got piston pumps, we got closed loop pumps, and then on an open loop pump you've got all these different classifications of horsepower and pressure comp and load sense. Load sense is one of the best things that came into the industry on an open loop pump, because what it did is give you the capability. If you're running a 20 GPM pump, you only need 5 GPM of that. It actually senses the work volume needed. So the pump will actually de-stroke and run at, per se, 5 GPM instead of always burning off an extra 15 horsepower. So greatly saving fuel, heat, everything that's ancillary, that goes around with that conversation. That's what hydraulic load sense is doing. We can and we do control pumps all the time, but load sense kind of does its own thing. And then when you look at this valve that's sitting right here, load sensing valves give us the ability to run a gear pump very similar to like a pressure compensated pump. So you can take a 20 GPM gear pump, which we all know is a fixed product, but you can shed off with some pressure drop. You shed off 15 gallons to keep it in the same context. And then you're running the loads with that. So you've got, pre-comp, you got post-comp. So different scenarios, but I don't want to get too deep, but I guess I wanted to get that in there because that is on there. And what we are showing in this drawing on the left is a can style valve, but there's many different styles. We're doing can because one of our main conversation points today is around the can architecture, the simplification of wiring, we're saving you time, increasing your communication, understanding what's happening. So that's why we have this one on there. And, it is a pretty cool product in that.
Right. Not to mention being able to integrate further with it, right? It gives you that flexibility for the future as well. So with that being said, I think we first wanted to touch on, that all being said, before we dive into our different systems of integration, first kind of, we'll show how we can simplify a system and maybe make it more CAN bus compatible, or CAN bus, or integrate CAN bus into it to make it telematics compatible, right? And so this is an application where we have a lot of these different applications. I don't know if you really want to touch on this, Trent, but
well, yeah, I guess I'll throw this in there because there's a lot of importance to this. So we've got, in this case, one of our customers that does multiples of these products. So, we're obviously not expanding out because this is something we worked on and we don't want to show everything, but it's a really cool point because like right here, this is the typical box, right? That was out in the field, was what we all seen, what a lot of us still do today, how we wire a mobile piece of equipment. So we're going to break that down, and the big takeaway of this at the end of this is what the time savings and the technology we do with it. So if you want to keep walking through, I guess I'll leave with that.
Yep. So I mean, as everybody can see in this picture, right? We've got a control panel here that is, to sum it up lightly, is very busy, right? Got a lot of switches, a low-level industrial PLC. We've got relay light modules. A lot of industrial wire terminations, terminal strips, heavy wire content. Obviously, everything you see here is point-to-point wire. There's not really any communication, so to speak. And then a lot of external circuit protection. And keep in mind, this is all industrial content, right? Not really any of it is IP rated or rated for harsh environments. Right. But a very busy panel, right?
And when we started this off, one of the main takeaways that is the customer wanted us to understand is not only was it taking them about 32 plus hours to build this, and them using one of their higher electrical engineers or electrical assemblers to put this together, they had environmental issues. They had, so this is on the rails, and this is going up into Canada and all the way down to the south. So it's up and down, but you're dealing with harsh temperature swings, you're dealing with humidity, you're dealing with very cold environments. as well as the motion, the vibration challenges. Anytime they had the problem, the machine would come back, and I think it was 80% of the time that the problem was within the panel.
Right.
So
exactly.
This is running a big piece of equipment. The problem was in the panel.
No, you make a great point that with all those environment or harsh environment conditions, right? Keep in mind that with all these terminations, every single one is a potential fail point. Which equates to a lot of potential fail points in this single product right here.
Yeah, and I think most people here, that's on this meeting can appreciate that fact. This is typically a scenario where there's sparks or a loose wire or whatever it was, because there's a lot of termination points here.
And with all those termination points and potential fail points, there's really no diagnostics for it, right? You need to manually go out here and troubleshoot this.
Right. Good point.
So this is kind of that's an overview of our original controls with this panel. Here's a picture or the final product of, and keep in mind, this is the same application. Does the exact same thing as the prior panel shown, but instead, obviously much cleaner. We got a mobile controller with internal circuit protection, no external circuit protection hardware. Everything's IP rated, so there is no water ingression. CAN bus communication, so not only is our controller CAN bus compatible, but all our external components like the switch module and the remote mounted I/O modules are CAN. And so it greatly simplifies your wiring, as it's obvious to see here, which also, moving to custom molded cables with plug and play connectors. I mean, it's overall just a very simple solution in contrast to, what it prior had looked like.
And the fun thing is around this conversation is the fact that when we started off this conversation with the OEM, keep in mind they put like 30 of these into their system. They built 30 of these for one piece of their equipment. So obviously the time savings is monstrous, right? We were like, well, we can greatly save that as we looked inside there, because it's very repetitive, repeat, repeat, repeat. So once we do one program on there, the rest of it's just plug and play, plug and play, plug and play. But he couldn't believe we could actually build this and make everything that was in the other one and do it all right here and make it work. So in this case, what they did is they literally, you're going to see on the next couple slides here, they literally created a mock setup and ran it and ran it and ran it and ran it to prove out that this could work. It could do the environments, it could do the shocks, it could do everything as stated and save them money. So right. The big point right here, right? Left is original, redesign on the right. And again, I think they are doing these boxes. They're coming plugged. I think it's like an hour and a half for them to populate a box. But I think one of the big pieces here to talk to is it's any low level type of labor can now assemble this.
Right. And not only are you doing your your labor and your hardware savings, but now you're going from a very busy, complicated system that was tough to troubleshoot to a smart CAN bus communication system, right? Which has all the diagnostics that you would need built into it, and simply a lot more cleaner and plug and play.
I think the fun thing here is that they actually decided to put it into a panel with a door on it, because you don't have to. This can be literally mounted out there because of all the IP ratings of where it's at. Even to the point where you can see the switches at the bottom right there are all the switches that were on the door before. So all those switches and all the lights that were on the door prior slide or on your left side over here is exactly the same, just done with a CAN style keypad switch. One plug, you're set, you're done. It's got diagnostics inside of it, but again, saving a ton of time, greatly enhancing their capabilities.
Right. So I think what we wanted to show here, and really has been shown in the prior slides, is that what a CAN wired solution looks like, or what it could look like, right? In retrospect to what may exist today. Obviously you've gone, you have your controller, your maybe a display, a switch module, the remote I/O modules, which we are we'd like to point out here. You're going from a very heavy wire content to something greatly significantly simplified, right?
Well, and I love this example, and that's why we're using it. This example, is virtually everybody's piece of equipment put on a table, assembled. Now, obviously, your piece of equipment will span over whatever space you have and whatever arms and tentacles and whatnot framework you have. But in this case, to what Kangas was just talking about is, if you look on the right side over here, which is a cutaway of the middle one, you've got an I/O module. So we call this distributed I/O. So what it does is it moves the high wiring points, like for the valve stack, which is where there's 6 valves there. So if you have that off in your corner of your machine, wherever it's 20 feet, 10 feet, 30 feet away, you would literally put one of these modules out there and then run 1 foot, 2 foot pieces of cord, which are M12 or Deutsch style connectors. But then you're only running one CAN communication wire going back. And that runs everything. That tells the valves to fire, it does diagnostics. So again, greatly simplifying everything going on, but making it simple, making it sealed very, very tightly, and making it very easy to install and get the wiring where it's supposed to be.
Exactly. Yeah, and I think, in addition to that wiring, you obviously eliminate a massive bulkhead connector, right? If you were to stick with just point-to-point wiring or wiring the control valve directly to the controller, you'd probably have a good 30 plus bulkhead connector at your panel there, which obviously takes a lot. It not only does it consume space, but it also takes a lot to create that. And then an additional point I want to make here is with these remote I/O modules, or really any CAN bus system, is you're not only commanding it, but you're also getting a lot more feedback from it as far as the state of it. Maybe you have current measuring capability within that I/O block, but in addition to that, you're also able to record or look at all the existing faults or failure points, failure status of the module itself.
Well, and I know on like 4 slides backward, we had the HMI on there, right? So nowadays, just like in our cars at home, our cars, or anything nowadays, we have an HMI screen. HMI screens at the very beginning, everybody told us, oh, we don't want an HMI screen. Well, it's the evolution of people putting them on their refrigerator, on their wash machine, and their cell phone. This tool right here was, kind of one of the biggest evolutions of everything happening. People wanted information, they want data, they want it instantaneous. Well, when you put an HMI screen on it, now you got the ability to actually communicate with everything that Kangos was just talking about. When you get a fault, you can bring it to your screen. You can do your start, stop, your push button stuff, but all that data comes back to you in any format that you want. And that's one of the things while you're working with the applied fluid power engineering team and sales groups, is you're going to be able to help design and focus in on what's important to you, what's important to your customer, how you want to see data. And we'll get deeper into this, but those are the big takeaways to really start vetting in. If you haven't done something like this yet, to start thinking about it.
Right. Yep. So moving on to system integration, I think we first want to touch on our system 1 integration here is more of a high level, right? Where most of the content you're seeing is, or pretty much all the content, this is a complete system package, right, from applied fluid power, starting with the sensors and transducers, which are connecting with the, the mobile controller or I/O module if need be. In addition to the CAN bus H-bridge modules, which are mounted out there by the actuators and controlled by the controller or HMI, via CAN bus, the HMI itself, and then in addition to all that, the IoT piece.
Right, and I think that we're using this one because it's real. It's happening right now. It's something that one of our OEMs are working with. We started talking with them about Isobus. We started talking about what they did. We started peeling back the layers of the onion to understand where their challenges were, what they're trying to get to. And along the way of discovery, which we do with all of our OEM customers, we start to vet through and start to understand what's problems, what do you want to do, what are you trying to solve. We started to see that they had a lot of the things that we've been talking at the beginning, a lot of point-to-point wiring, major labor issues, a lot of diagnostic issues in the field, wiring problems, fault problems. All of this stuff was happening. And again, you've got an operator up there who's just trying to run a piece of equipment. and he doesn't know what's happening on this piece of equipment. And I'm not going to go into the detail because we always protect our customers and their IP and with their stuff. And, you know, the information here is, you know, just baseline stuff. But I thought it was a great piece because as we started peeling those back, they're like, yeah, we have problems with this. We have problems with this. What can you do? And we started creating a solution that greatly cleaned up what they did. And they want more and more and more because, again, they have labor issues, they have technology issues. All of these things started to come to be. And that's why I like this one, because this is real. This is happening still today.
Exactly. No, and that's a great point. Not only are you cleaning up, you know, when you move to a CAN bus system versus point-to-point wiring, not only are you cleaning it up and you know, making it smarter, but you're making it accessible to the IoT piece. Whether you put it in initially or not, it's at least compatible for down the road.
And maybe a good time to break down IoT, right? We should probably break it down because today, you know, we hear it as telematics, telemetrics, IoT, IIoT. You know, all of these scenarios are happening out there. But what it does, it's a piece of hardware that we're putting onto equipment, and we're going to break it through these next three systems, whether it's existing, created, mid-stage or high level. What we can do is put that on there. But one of the biggest things that we really found out through this last pandemic, you know, as unfortunate as this was, is a great majority of us, virtually everyone, we're not able to get on planes. We're not able to fly anywhere. We couldn't get to our customers, right? So we're an OEM, we're a smaller OEM. We don't have a distribution network all around the world like John Deere, et cetera. We couldn't get to our customers. Our customers were still running the machines, but they couldn't see or help diagnose what was going on. You know, the IoT piece right now is really solid because all of this happened in the same time frame where we were developing a platform to solve these issues. And what this does, King, if you want to give them an idea, kind of break that piece down.
Yeah, I was just going to say, in addition to, you know, as far as IoT goes, in addition to troubleshooting, you know, whether it's diagnostics or whether you're using it for maintenance or fleet management, in addition to that, you know, in a complete solution like this, we're actually able to, you know, remotely flash the devices such as the HMI and the controller remotely, whether that's just an update, et cetera. There's a lot of capabilities with the IoT piece. And like Trent mentioned, it's only getting becoming more and more you know, important now with our current stance today. So
we'll get deeper into the IoT piece here at the end. Plus, keep in mind we've got, you know, this is a series of 4 webinars we're having, advancing the conversation around IIoT, around this, you know, kind of advancing that piece forward. Because it is new, it is different. What we'll show through this series is, you know, how this can greatly impact your ability to, you know, service your customers. How does it impact the ability to not increase your engineering resource team because you have a piece of equipment down on one side of the country and you've got another piece down? But as a smaller OEM or a mid-sized OEM, this gives you the ability to have that reach, because we all know it's about uptime. You know, you're judged by your customer performance of your machine and how you service me as a customer. So those are the pieces, and that's what this does. It gives you that information, and we'll break that down and get deeper into it. But we definitely want to cover it because you're going to start seeing it. It's in our architecture. It's not a mandatory piece, but it's something you might want to consider.
Right. So in concluding with System 1 integration here, we're essentially looking at a complete package, right? We've got the sensors, transducers, controller, I/O modules such as the H-bridge modules shown here, the HMI, the IoT piece, complete package, right? Whereas now when we're moving next to System 2 integration, we're moving more towards a medium level, where maybe we're not supplying all those pieces, right? Or maybe some of those pieces exist or don't exist, but we're still able to integrate with it. So maybe in this case, we have the controller, the HMI, or in the IoT piece, and we're and also the power distribution module, right? But maybe we're integrating with, you know, the existing engine or the customer's engine or third-party components such as a joystick, whatever it may have you.
Yeah, I mean, you bring up a really good topic right here, right? Again, we're showing the IoT piece on here, not mandatory. However, greatly enhances everything in here in system 2 level integration, right? So that medium piece. So again, this is your system today, however this is being plugged in, right? You know, adding the power distribution module on there, greatly enhancing your capabilities by not having to put that box with all the different relays in there. Again, we're communicating back and forth where we can. We're telling it, because this is a high amperage piece. I think this is a 200 amp device. So you have the ability to run all your lights, your air conditioners, all these different pieces happening around your piece of equipment. You can actually run through the same architecture by just simply sending a message. You lay it out to where you want it, send a message, plug your connections in, you're running. So again, greatly simplifying everything, running from your HMI screen or adding CAN key bus switches or adding switches into this. You just lay them in, you know, in a continuous line here. You got the, you know, your yellow and your green lines on here. You just keep plugging pieces in. Again,
I think a big thing I want to, sorry, Trent, go ahead.
No, go for it.
I was just going to say a big piece I want to really point out here with the system 2 integration or medium level integration is that we're not only integrating applied fluid power components such as, you know, the ones labeled here, but or really have access to them and that data on the CAN bus with the IoT piece, but we also have access to all the engine data. We have access to all the joystick data or whatever else, you know, what other devices or hardware may exist on that network. You know, it's totally adaptable.
Yeah, awesome point, because it is totally adaptable and completely flexible. So whatever the data that we're receiving in or putting out or sending to, doesn't really matter. We can pull some of the different data. We can run multiple things. We can code to it. We can change joysticks around. We can redo it. All those different things. And if you do have an IoT piece on there, you have the ability to actually shoot messages to it and pull data from it, but you can actually do a reprogram. You can do an update. You can do a program enhancement. The customer says, hey, I want to switch this to this instead of this because this is how my operators are. Or we can do that, and you can do that from your desk.
Yep. Yeah, there's a lot of capabilities with that. It's just, it really all comes down to, you know, what are your needs and you know, what exactly are you looking to record. So moving away from, moving one step further down from a you know, medium level integration to a lower level integration. And when I say a lower level integration, maybe all we're doing is supplying the IoT piece, right? Maybe there's an existing system out there, whether it has an HMI or controller, all being third party or just owned specifically by the customer, engines, valves, joysticks, whatever have you. It's all still possible, right? We're all still, as long as we can plug into it with the CAN bus, you can certainly still add the IoT piece to you know, any type of application. And maybe we're kind of showing like an excavator here, maybe not in a likely scenario, but it could be something of relevance, right?
Yeah, I mean, and again, you can go to applied fluid power. You can go to the drop-down box on our, you know, integrated solutions area. You can see the IoT information. You can kind of go through. There's a lot more data on there. Again, this is designed to have, you know, 4 different sessions, right? So but at any point you want to get some more data, you can go on there. We got our brochures on there. You can download off applied fluid power, and you can go to the sections. You can see it. You can walk through and get a better understanding that more of what we'll cover today. But at any point, if you want, you can obviously reach out to myself, Trent Teg, or Kangas, or any one of our people. You can reach out, and we'll have information showing who to contact, what our numbers are. But if this is of interest of you for today, you can jump right into it.
Right. And in addition to, you know, when we look at this piece here with the you know, at a low level integration, not only are you maybe getting the diagnostics and maintenance and analytics, depending on your system, you potentially could still get the remote flashing. Maybe not as likely as if, you know, it's an applied fluid power controller or display, but there's still always the potential.
Yeah, always, those are the scenarios, right? So we talk about a very broad scale of stuff. The next piece is you sit with one of the applied fluid power engineers or the sales people across the nation, and then we break down that conversation, right? We peel back the layers of the onion. We start to understand what you're trying to do, what your challenges are, what your outcome you want is. We pull that back and we work with you to develop this. Because keep in mind, we do from the very beginning to the very end, or we jump into the middle and work to the end, or we add on to the end. So that's what this 3-level piece is, right? So existing piece of equipment, an upgrade to the piece of equipment, or a full design piece. I mean, that's what applied fluid power does as a whole.
Exactly. Yep. No, that's a great point. So now that we've kind of looked at system integration and maybe the different levels of integration, probably wondering, how do I integrate telematics into my control system? Number one, you got to select your solution, right? So ideally you have an idea of what you're looking to do with telematics, or maybe what you want to view, whether that's diagnostics or maintenance or fleet management, whatever may have you. You kind of gather those details, then kind of pick from this 3-tier level. When we're talking about mobile equipment, or really any type of control system, mobile control system, you're really going to be focused on number 2 and 3. Number 1's more of an industrial application. Maybe you want to touch a little bit on that, Trent.
Well, so as he's referring to, number 1 is more of a reporting diagnostics piece, right? So if you got power units, whatever it may be, sitting out in an industrial plant, you want to read pressure switches, temperature switches, dirty filters, fans, whatever it is. This is a simple plug and play where you put the module in, you take your information, tie it into your module. You can now literally through the app, set it up, go to it, see what it is, set your parameters, set your gauges. About a 15-minute application minus, how it takes, whatever it takes you to wire it up. So whatever your skill set is to wire that on there and get the power to it, and then run your wires over to it. Setting that app up, about a 15-minute, a lot of pre-configured gauges and such. But we're definitely seeing a ton of this in the industrial piece, because people really want to understand where we're at.
Right. Yeah, and once you're, number 2, once you're talking about connecting and configuring, once you've selected your what you want to do with it in your device, now we're talking about connecting and configuring it. For the most part, it's really as simple as connecting power and hooking it into the CAN bus backbone. From there, it's whatever you would like to record, whatever exists on that CAN bus, and maybe even some additional limited I/O, right? The options are wide open.
Yep, absolutely. So this is kind of our 3-piece, right? But the 3-piece setup is the third piece is definitely more around a more a la carte feel, where we're working with you to really understand what you're trying to accomplish, how you want to configure, how do you want to be able to flash new updates to your screens, on your HMI screens, do diagnostics. We're working with you on a very customized solution. 1 and 2, 1 much more industrial, 2 much more plug and play, sending some data, can't communicate back to it, but sending and receiving data. 3 are more exclusive piece where we're working with you in our engineering team. But once again, to apply that, as you can see on the right, the wiring is pretty simple. It's 4 wires, 5 wires, depending on what we're doing. J1939 engine communication piece, we can tie right into that. It's still an easy piece, and one of our engineer IoT experts, Adam Fagan, who worked on this, has done multiple machines where he shows up at a customer and he puts them on in 15 some minutes, and he's sending the machine on the field, and he's literally watching it on his computer screen. So yeah. Still pretty simple. Right.
One thing I do want to point out that you reminded me of too is there's a lot of scenarios where you get to number 1, select your solution, right? And maybe you're not entirely sure exactly what you want to do with telematics, but the beauty of it is usually there's a lot of flexibility there. There's many scenarios where we'll put telematics on a customer's machine and they say, hey, we want 1, 2, 3. But in the end, it usually ends up getting exploded because you don't even realize what your capabilities are, or even maybe how far you want to take it until you actually go put it on the machine.
Yeah, I mean, we pretty much we start with new prototyping machines, because new prototyping is, as we all know, we don't know how much horsepower is needed. We don't know if do we oversize, do we undersize, what's the real use condition look like, or how's the operator actually using it. We always push now to get this out there, because whether the customer, where the customer's at in the country, we can actually see this piece of equipment running. We can get operator, and it's recording data, right? So all of this is just constantly recording, sending a blip up there to the cloud so we can pull the data. So at any given point, the customer said, hey, this happened during the time frame. We can literally go back to that timestamp, and if he knew what time it was, we could see what the blip was. And so greatly enhancing our capabilities to select the right engine, select the right pumps, change parameters. They're using it this way instead of this way. Warranty considerations, all of that is huge. And to Kangus's point, once our customers get this on from a prototype standpoint, they're like, wow, this is very, very powerful, because I can reach that piece of equipment anywhere in the country at any given time with, again, our thought processes, without expanding the engineering team. Because we all know today it's very hard to expand your teams, because people and resources are difficult. But I can do it from a desk without jumping on an airplane, without driving across town, without this, So these are very important pieces to the IoT piece. And as you can tell, we're really talking about it, but keep in mind, we live in this world, and this product has greatly simplified our lives from an engineering and application side of the fence. What it does for our OEMs, we're building machines and sending them around the country, 10, 20, 30, 100 plus machines a year. This is greatly enhancing their abilities.
Exactly.
All right. Well, I think we're to the end here, right?
I believe we are.
So I appreciate everybody's time and attention over the last approximately 40 minutes. I think we've gone through a ton of different technologies and how things have changed in the industry. And again, at any given time, you're looking to add this instantaneously or work with one of our engineers, just reach out, because this, as stated at the very end along the way, this is a 3-part series, but that doesn't mean you can't jump in right now. We can start a conversation with engineering through myself or Trent Kangas or any one of our other engineers or sales groups across the nation. You just reach out to us at one of the links, and our names and information will be at the very end of this. Again, April 19th, May 19th, and June. We will be having a follow-up to these sessions, going deeper into the beast of the whole IoT, the control system. Just click the link, and we'll also be having an SRQ code you can scan. So have your phones ready, you can scan that and automatically join up through your smartphone. But other than that, thanks everybody, and thanks Kangas for helping me, walk everybody through this new and exciting technology. And we'll move on. Have a great day, everybody.
Thank you, everyone.